Good afternoon, ladies and gentlemen. This is Professor David J. De Los Reyes, an electrical engineer by profession. I am from Asia, guys. It's the Philippines. I've been here in the USA for almost 30 years. So actually, I'm a US citizen. Okay, good afternoon. My lesson for today, for those who are following my channel, we are now on the topic differential equation, okay? That's the third course under my channel. And under the differential equation subject matter, I am now on DE 21, meaning differential equation, lesson number 21, differential equation. The topic this afternoon, for those who are following me, will be differential equation solvable by using integrating factor. Integrating factors. I am done with the solution of differential equation under the so-called variable separable. And I am done also for the solution of differential equation, that is the homogeneous type of differential equation. And this is the third topic on my course differential equation. It is a differential equation solvable by using integrating factor. Solvable by using integrating factor, IL. So this is a new topic. So this afternoon, I will discuss the concept of the solution by using an integrating factor. We are to consider for the meantime linear equation only of a first order. Okay, first order, meaning the power is actually 1. Okay, there are two cases under the solution for differential equation solvable by using integrating factor. We got two cases, case number 1 and case number 2. I will give you the two cases, then I will try to derive the formula, okay, on how to solve the two cases. I will just give you one. The other one is just the reverse of the other. Okay, I will give you case number 1. Case number 1. If the given differential equation is of the form dy dx plus p of x times y equal to q of x, okay? The integrating factor for case number 1, if the form is something like this, the integrating factor will be e raised to, this is the complete exponent. The complete exponent is the integral of p of x dx. And that is the integrating factor for case number 1. If the given equation is of case number 1, that is dy dx plus p of x times y equal to q of x. This is x, and this should be dx. Okay? So it should conform. The integrating factor is actually e raised to the integral of p of x dx. And the solution, I will give you the solution, but I will give you the proof. It will be y times the integrating factor, and this should be equal to the integral of q of x times the integrating factor multiplied by dx plus c. That's the solution for case number 1. So meaning to say, if this will be the solution, to bring out the total solution, you must have to integrate the right-hand side. What will come out on the right-hand side, pray that it will be an easy thing, okay? Because if you could not evaluate the integral, you cannot bring out the solution. Okay? But a part of the solution is actually on the left-hand side, it is y times the integrating factor equal to the integral of q of x times the integrating factor times dx plus c. That is case number 1. Case number 2. It is the reverse of the first one. Instead of dy dx, it should be dx dy. If the given equation is dx over dy plus r of y times x, okay, equal to s of y. The integrating factor will be, it's different from case number 1. The integrating factor will be e raised to the integral of r of y dy, r of y dy. The total exponent of the integrating factor is r as a function of y times dy. And the solution for case number 2, it will be x. Okay, this is x on the numerator, so this should be x times the integrating factor equal to the integral of s of y, the given right hand side, times the integrating factor, okay, r of y dy. You see the difference? This is p of x dx, this is r of y dy. Because we are on case number 2, times dy. Because the first one is dx, this is plus c. Because case 2 is just the reverse of case number 1. So actually, you could imagine case number 2 by just going back to case number 1 by just replacing the variables. Okay, so final answer for case number 2, it will be x times the integrating factor equal to the integral of s of y, the given right hand side, times the integrating factor times dy. Okay, let's see. These are only the 2 general solutions for problems involving using integrating factors. Okay, let's try to bring out this solution here. Why it came out like this. For case number 1, derivation of the general solution. The given equation is actually dy dx plus p of x times y equal to a cube x. This is given, right? For case number 1. Okay, multiplying all terms by dx, this will become, I'll remove this one. Multiply all terms by dx. Okay, left hand side, what will remain will be dy because dx cancel with this. Second term will be p of x times y times dx equal to q of x times dx. This now got a dx, and so this one after the multiplication of this. This dx and the first one cancels. Okay, so what will remain will be dy plus p of x times y times dx equal to q of x times dx. And for case number 1, as a general rule, it was derived. The integrating factor is actually e raised to the integral of p of x dx. This is standard. No matter what happened in this world, the integrating factor for case number 1 will always be e raised to the integral of p of x dx. Integrating factor. And what's the significance of that integrating factor? We try to multiply the integrating factor for the whole equation. Okay, let's try to multiply. This is the integrating factor, okay, times this. I just rewrite it, equal to the right hand side. So meaning all the terms for both the left and right we will multiply by the integrating factor. And if we try to expand, the first expansion is this one. Right? The second expansion is this integrating factor times this. So I just rearrange, I go with the y first, times the integrating factor, okay, times p of x dx. P of x times dx. Okay, I just rearrange, but I multiplied it already. The right hand side will be the integrating factor times q of x dx. If you try to notice the expansion after the multiplication, this one. If you try to notice it, this expansion is actually the product of the differential of y times e to the integral of p of x dx. Because if you try to take the differential of this, what will come out is the total left hand side. You could do it yourself or you could do it visually. First one times the differential of the second plus the second times the differential of the first, what will come out is this one. The left hand side. So actually the left hand side could be summarized as simply the differential of the product of y times the integrating factor, and this should be equal to the right hand side for the meantime as it is. It will be the integrating factor times q of x dx. Okay, then try to take the integral of both sides. Okay? Left hand side, the integral of the differential of this product here, the integral and differential go near each other, they will try to cancel out each other. So after taking the integral, what will come out is just simply like that. The product of, after the integration of the differential, it will come out as simply the product of the terms inside, equal to the right hand side. We cannot do anything for the meantime. We do not know the value yet, so we just write it as it is. So they should be equal to the integral. I just write this one first, q of x times the integrating factor. So for this one, they should be multiplied by the x. Okay? So the general solution for case number 1 now will be y times the integrating factor equal to the integral of q of x times the integrating factor, this is multiplied by dx. Let's see. There should be a dx. Okay? I missed the dx here. So the right hand side will be the integral of q of x times integrating factor times dx plus c. And this equation here is actually this equation. Okay, that's the derivation of the general solution under case number 1. That is y times the integrating factor equal to q of x, the integral of q of x, times the integrating factor multiplied by dx plus c. It is this. To derive case number 2, it will be the same process. We will just reverse the variables. So I will not show you anymore. It's the same as this one. Okay, I will repeat for case number 2. For case number 2, if the given equation is dx dy plus r of y of x equal to s of y, the integrating factor is e to the integral of r of y dy, and the solution will be x. Just reverse this one. Instead of y, it will be x times the integrating factor, the integral of, we replace that q of x by s of y because the given right hand side is s of y. E raised to the integral of r of y dy, because this is r of y times dy plus c. That is case number 2. The solution is still the same, you just replace the variables. Okay guys, that's the concept of the solution of his so-called differential equation, solvable by using integrating factor. This is just the concept. My next lesson will be example problems on the evaluation of the differential equation, solvable by using integrating factors. Okay, good afternoon, Los Angeles. This is the solution of the differential equation, solvable by using integrating factors. Case number 1 and case number 2. Good afternoon, Los Angeles.